solve for x. First one, which talks about the length of the altitude, right? Alright, so we'll put on here, we'll actually get down here to some playing room. Alright, so we know that the length of the altitude, x, is the geometric mean, so get the square root of what? So 8 times 3. Okay, so what is 8 times 3? Can the square root of 24 be broken down? To what? So root 4 times root 6. And what's the square root of 4? 2 right after 6. And the square root of 6 be broken down? Alright, now 2 and 3, are either of those perfect squares? So we're done. We just found the value of x. It's 2 radical 6. How would I find the value of y? Okay, we're going to use the second one. The second one tells me that the length of the segment, okay, so the length of my leg is the geometric mean of the whole hypotenuse. So how long is my entire hypotenuse? 11. And we do something a little bit different here, just so you guys kind of see how I'm setting this up. So 8 plus 3 times, now which piece is adjacent to the y? The 3 or the 8? Let's take a closer look at that. Which one's adjacent to y? The 3. Alright, you guys already told me that the 8 plus 3 is 11, 3, let's go to 33. Can that be broken down? And there's your 2 answers. All right, questions on that? Not too bad? Maybe. All right, here's our next problem. Where do you guys want to start? Because this problem can get really nasty depending on where you start.
Sure, what's the easiest?
Well, which one is the easiest? You have very limited information here, don't we? Well, let's just start. Oh, go ahead.
Do you add 9 plus 9?
Why 9 plus 9?
Because only half of it is 9.
Are we told that that altitude splits the hypotenuse? No. Okay, so we can't assume that the other side's 9.
Well,
let's try this. Let's try solving. Oh, go ahead, Brian. Only in the 30, 60, 90. So we don't know anything about the other angles. All we know is that we have a right angle. Let's try this. Let's try start solving for y. This seems pretty simple. So y should be the square root of the 2 parts of the hypotenuse, right? Well, we already know one part. What's that one part? 9. And then it's 9 times something else. What is that something else? Do we know what that other part is? No, x is the whole thing. Great question here. Let's try this. Let's do a little lemma. Problem off to the side. I've got a segment. I'm going to say that that segment is 25 units. And that would tell you that at this point, this length is 7 units. What's the length of that missing portion?
18.
Sarah, how'd you get that?
So
So you took the whole and subtracted the given portion. So 25 minus 7, right? How it's probably different if I told you that the whole thing was x. What's the length of this side? X minus 7. Yeah, one order matters here. Okay. You're taking the whole and subtracting the portion. Okay. All right. So we found that missing portion, took the whole and subtracted our portion. So back here, if my whole is x and this is 9, then what is the length of this segment? X minus 9. Can I solve that problem? It's a little louder, Brian.
Would be 9x minus 81.
Yes, but am I still able to solve that problem? Can I still solve for y? You get a lot of quiet faces here. What's the problem here? Should be like one of those algebra 1 red flags going. What's the problem with the situation? So, and we're solving for y. So we have 2 variables. That's a big problem. So if only we can figure out what x was, and then I could solve for y. Well, that means we gotta scratch our heads a little bit further. Okay, what else do we know in this problem? There's gotta be another way. What else do we know? Even if it seems ridiculous to state it, what else do we know? Y is adjacent to 6. Okay, what else do we know?
45, 45.
No, do not make that assumption. We do not know that. Keep thinking, what else do we know? It's very close to what Alyssa just said. What other number have we not used yet? 6. Well, there might be a way that the 6 is going to tie into this. Does the 6 represent a leg or the hypotenuse of the big triangle? It represents the leg. Remember, we just learned that the leg, so that in this case 6, is the geometric mean of the whole hypotenuse, x, and then the portion of the hypotenuse adjacent to 6, which we said was x minus 9. Okay, so from there we're going to go forward. So 6 is equal to the square root of x squared minus 9x. And it might seem like, I know what we can do. Let's take the square root of x squared and we're done. Unfortunately, things don't work out that well for us. Okay? If you're adding, subtracting anything to radical, there's nothing you can really do other than try to get rid of the radical. How do I get rid of my radical? How do we cancel out the root?
Square.
Really? No, you're not multiplying by 2. Sam?
Square.
You square it. And so my next step is then to square both sides. And then the square root and the square will cancel. And I'm left with 36 equals x squared minus 9x. What type of equation did I just create? It's one of those equations most of you guys absolutely despise. It's a quadratic. Anytime we need to solve a quadratic, what do we have to do? Set it equal to 0. So what do I have to do in order to do that?
Subtract.
Subtract 36. So 0 equals x squared minus 9x minus 36. Now, there's several things you can do here. You could factor it, you could graph it, you could use quadratic formula. All of those will get you the same answer. My goal when I do these is to try to factor first. And then if that doesn't work out for me, then we'll go to the quadratic formula. So remember with factoring, you're looking for two numbers that multiply, give you the last number, but add to give you the middle number. So what two numbers could I multiply to give me negative 36, but add to give me negative 9?
Negative 12 and positive 3.
Negative 12 and positive 3. So x minus 12 and x plus 3. Now those are my factors. Well, what are my solutions? Mackenzie? Well, I know, okay, they seem confusing, but it's really not that bad. What would make this parentheses right here equal to 0? What would x have to be? Have to be positive 12. And on this one, the x would have to be. So mathematically, we had two solutions. But do we really? We really had two solutions here. Let's go back and look at the original problem. Could x be 12? Could x be negative 3? No, you can't have a negative length. So that's what we call the extraneous solution. It's a solution that doesn't make any sense. Okay, so therefore x is 12. That was a lot of work just to get one single variable. Well, once you have it, everything else falls into place. So we're going to take the 12, and we'll plug it in over here for the y. So y is equal to the square root of 9 times 12 minus 9. Y equals the square root of 9 times 3, which then gives us 3 radical 3. There we go. So that was fun. Oh, then you got it. This is a tough one. This is one of those tough lessons. Let's take a look at one more.